How you going, everybody? My name is Lonnie Hem. I'm from Monash University in Australia, and I'm doing an education course. Now, one of the assignments for my IT method was to produce a software that was designed to teach students a certain concept in physics. Now, just to show you, this is my radioactivity decay series tutor that I programmed in visualbasics.net. So I'll just run it. There you are. Now, what this does is it will teach the Year 11 VCE Physics Unit 1 radioactivity decay series. There's two small parts. There's half-life and decay, and this is the decay series program. Now, this program is designed to test the students' knowledge in identifying the alpha or beta decays and also graphing the series. So just a rundown of how the program works. Pretty much it will say is generate a new decay series, and you can click generate here and you generate random decay series. So it could be long, could be short, depending on the type of series it is. And it randomly generates three types of series. There is the NP series, which is the Neptunium series, and there's variations of that. Then there's a Thorium series, and there's a few variations of that. And I'll see if I can, yeah, there it is, and that's the uranium series. Now, after generating the series, it will break down the series into its components. So the first phase is, and this is the second phase, is the third phase. Each phase represents a type of decay. Now, in the first phase, it's a decay from uranium-238 to thorium-234. This is obviously the students would have a background understanding of decay, and this is for them to come in and revise and really get down and learn exactly the decay series. So this is pretty much the format I followed here. Was kind of like the worksheet format that I've given out in the previous rounds of teaching. So this one is an alpha. Now, because and this one would be a beta decay because the atomic mass hasn't changed, but the elements have changed, and students would go through and choose the correct one. I'm going to make a mistake. This is an alpha, but I'll make it a beta, and this is an alpha. This is a beta, alpha, and I'll make another mistake. I'll call that a beta. And this is a beta and a beta. Now, after the students have done this, they can click check answer, and they'll see how much they got right. Now, I made two mistakes deliberately, so it's 12 out of 14. Now, you can't do it. You can only do it once, so they can't, fix it up and try to do it again. So this is good, so that they got to get their answer right. After that, what they'll end up doing is start graphing it. So they'll go one by one and graph it. So it starts at the 238, and that's uranium. Uranium's atomic number is 92. The only way they know how that is to check a periodic table. So when they're doing this, they'll have to have a periodic table in front of them so that they know that uranium is 22, thorium would be 90. So they know that if they look at a periodic table, they know that the next point would be thorium, and the atomic mass is 234. So 234 is here. So the next, because it's an alpha decay, it will decay from uranium to thorium, which is there. So they can click it there. And then when they click it, the answer appears, and then they got it right, So another one, so they'll just keep going through it. Now the next series would be a alpha decay. Alpha decay loses 2 protons and loses 2 neutrons, so it moves across 2, but then it moves down 4 because it's lost 4 in total, 4 nucleons in total. So it should go to about there. Okay, no, whoops, that was meant to be a beta decay. That was meant to be a beta decay. So I made a mistake there. So as you can see, making the mistake, it shows you, oh, it's not an alpha decay, it's a beta decay, so it moves there. So the next one is a beta decay. I changed it before, that's why I got confused. So I'll click here. A beta decay is move 1 here, so that's right. And the next one is a alpha decay, so that should be here. And then they just keep going, so they just keep, keep trying to get it right, and they see if they're getting it right. And if if they make a mistake, it will still tell you which one the right answer is until it ends, pretty much. So that's it, end. Can't do anything else, it's locked. So we can generate a new series and they can practice again, so they can find the right answer again, check their answer, graph it. Now you notice here, every time I click on it, it tells you, oh, it's a Neptune series, so it starts here. And then the first one's an alpha decay, therefore it will lose 2, and explains what an alpha decay is and why it has moved, graphs it there. So the next one is a beta decay, so I click here and it goes, oh, you're correct, it is a beta decay, therefore it emits a neutron, electron, and gains a proton, and then because it gains a proton is atomic number of 1, it adds 1, so that's why it moves that way. So this is pretty much my decay series tutor. Now the way I've designed is that you can generate up here and then you just work your way downward and you click your answer there and you can graph it there. So it's pretty much working in columns. You work down and you work down again. That's why I've kind of set it up like that. And also I've also originally had the graph protruding out this way, but now I've put the atomic number on top because it saves space in this section here. What else should I talk about? Also, there are a few bugs, as I've haven't fully ironed it all out, even though this is pretty much a working alpha version that you can still use. But when you generate a series, if you graph first and you can't do anything until you click both of these, then you can start clicking. But you notice that this thing doesn't disappear here. Start graphing, clicking on the graph. If I were to go in series, it's perfect. But if I were to graph and then click that first and click there, then I can start moving. Now I don't necessarily have to click. Hold on, let me just show you something. We graph. Let's say I click here. Don't necessarily have to click on the graph, as you can see here. If you click on the graph, let me just go. If you click on the graph, then it actually graphs it. But if you don't click on the graph, it still keeps going. So that's something might iron out in the future. Another thing I'd like to improve on it in the future is make it generate different shaped graphs. For example, instead of being atomic number there, these two are interchanged. Maybe I could also randomly make it go from 93 to 80 that way, or 238 and 206 that way, because in the exam or the test, these graphs can be shown in different ways just to throw students off. So if I could make this randomly generate different shaped graphs, this would help the students be more familiar with, rather than just actually have to count backwards or forwards on this. Oh, there is one other thing that you probably noticed that I haven't actually explicitly said. If you, as you graph, this highlights telling you where we're at, so that you don't get confused as well. Anyway, that is very much the reason why I've designed it in such a way. Well, I hope this is adequate for my presentation and also the information required for this assignment. Yep. So thank you for your time, and enjoy the rest of your day. Thank you.